Okay, slight interruption. We've typed that into the calculator and that's our answer. So we're going to write that in. Usually write several decimal places first. 11.05011 ... and then round it off to 3 significant figures.
Yep. And
Okay.
don't forget those units.
Units, yep. And notice that we haven't used the calculator until the very last step. This will save us writing out lots of digits halfway through. So only get your calculator out in the very, very last step.
And also, if we think about if our answer makes sense, if we have a look that the side we were trying to find was 11.1 and it's opposite 32. The side that's opposite 46 is bigger. That makes sense because the size of the angle and its side opposite should correspond. So a bigger side should be opposite a bigger angle.
Yep.
So we can see that our answer does make some sense.
Yeah, it does.
All right,
Good.
let's have a look at finding an angle then using the sine rule.
Okay.
All right, so this time we don't even have any labels on our triangle, which is fine. We don't need them because remember, we could call them anything we like. The important thing again is the order, where they're placed. So we're looking for the angle x. We want the side opposite, which we do know, so that's good. So remember we said before, it's easier and quicker if we write the signs on top when we're trying to find the angle. So we'd have sine x over its opposite side, so over 13, and that'll be equal to another pair, so we know sine 35, and opposite its opposite side of 20. Then doing some simple algebra work, it's divided by 13, so we multiply both sides by 13.
Oops, sorry, 13.
Over 20. And we almost have x by itself, and it's not quite by itself, and we know from our right angle trig that to get x by itself, we perform the inverse operation. So we take sine inverse of all of that stuff there. Now, good idea to write it all out first. When you put it in the calculator, you might want to just do the bit that's in brackets to begin with and get the answer, and then take sine inverse. So if we just put it in, and we have 13 sine 35, again, don't forget to close the bracket there, divided by 20. So that's what 13 sine 35 divided by 20 is, and then we need to take the inverse sine of that answer. And so we get x equals 21 point...
Oh,
oops.
oh, I think it's the one directly underneath it. There we go. So x equals 21.8899,
etc. Round into 3 significant figures, and it's degrees.
Yep.
So that's the sine rule.
Yep.
And all you need to remember is just to get the right pairs, the right angle and with the right side.
Excellent. Mr. D, if you need to go and do your duty, you can go. Shall I carry on with the cosine rule?
Yeah.
Okay. So we're just going to have a quick look at the cosine rule, which is another rule that can be used for non-right angle triangles. This one looks a little bit more complicated, but it's not too bad. Okay, so the basic principles are the same. We start with the correct labeling, and there are 3 forms of the rule. So depending on which angle you're looking at, but really you only need to look at one of them. Okay, so if we try and interpret this rule, it says that this side squared, for example, is the same as the sum of the other 2 sides squared minus the product of, so double the 2 sides times the cos of the angle in between them. Okay, right. And the question is, when do you use this rule? You use this rule when, and I need you to learn this phrase, the phrase that says, "'cause I need a sandwich," and it is lunchtime almost. Okay, you need to learn this phrase, "'cause I need a sandwich," because you use the cosine rule whenever you have an angle, whenever you're interested in an angle that is sandwiched in the middle of 2 other sides. We'll look at an example, I think is easier rather than talk in theory. So here's our example. I'm going to start by writing the rule so that we've got it accessible. It says a squared equals the sum of the other 2 sides squared minus 2 times the other 2 sides times cos of the angle that matches with the original side. Okay? So in this case, our x value is not actually written down. Our x value is this one. Okay? So this is the side that we are trying to find. Now, can you see how you've got, the information that you've got is an angle sandwich. You've got an angle sandwiched in between two sides, and that's why we're using the cosine rule, because I need a sandwich. All right, so let's try and put these numbers into this formula. Again, as we said before, rather than relabel the triangle ABC, it's easier just to see what goes with what. So the missing thing is x. So that's going to go instead of a. Okay? So this side squared equals the sum of the other two sides squared. So that squared plus that squared minus 2 times the two sides. So 10.3 times 14.8 times cos of the angle that is opposite x and that is also sandwiched in between the two sides. So cos 72. Okay, so lots of nasty calculations there, but they can all be typed into the calculator. Now, just to make sure I don't lose things, okay, so let's find the calculator. See if I can do this at the same time. Okay, so we're going to type all of this into our calculator. It gives us 10.3 squared. Now, it's actually easier, I think, in this case to type it all in one go, but just be very careful. The calculator will do PEMDAS, so we're okay with that, but just be careful not to miss anything. So 10.3 squared plus 14.8 squared minus 2 times 10.3 times 14.8 times cos of 72. Okay, and that gives us 230.916. So let's write that down. Oh, sorry. X squared equals 230.916, I think it was. Okay, 916, etc. Now we've not quite finished because we need to find x, so to get rid of the square we need to square root our answer. So if we go back to here and if we apply the square root, which is this one, square root of our previous answer, no, not that, then we should get an answer, 15.195. So 15.1959, etc. gives us roughly x equals 15.2. And this is meters in this case. And again, just check, as Ms. Adi said, that your answer is reasonable. Yep, 10.3, 14.8. It's reasonable for that side to be 15.2. Okay, let's see if there's an example for finding a